Slant asymptotes happen sometimes if a horizontal asymptote does not. So when you guys had your 2.681 notes, you had horizontal asymptotes. The first was if the degree of the numerator was less than the degree of the denominator, the horizontal asymptote was what? 0. If the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is what? Ratio of the two leading coefficients. If the degree of the numerator is greater than the degree of the denominator? None.
None
But. Here's your but. But. Okay, here's your but. If the degree of the numerator is exactly 1 more than the degree of the denominator, the graph of the function has a slant asymptote or an oblique asymptote found by using long division. So if the degree of the numerator is greater than the degree of the denominator by exactly how much? 1. You have a slant asymptote, and the slant asymptote is found using long division. The top is what you already have written. It's what you should be putting your but underneath. No, you should have that part. So if you look at my picture real quick, if I divide something like a third degree by a second degree, my answer is going to be a first degree, correct? Because there's one difference between the two. What kind of a line is this slant asymptote right here? Well, it is imaginary, but what kind of a line? Is it quadratic, cubic, linear, quartic, quintic? No, this is linear.
Oh, linear.
Hey, we are going to find that y equals x minus 2 using long division. I don't care about the remainder. All I want is my y equals mx plus b. I want my y-intercept and I want my slope. That's all I want. Personally, when I do these, I do not use my y-intercept and my slope to graph them. I use the y-intercept and I find the x-intercept. Because when these are sketches, yes? And if I know where it crosses the y-axis and I calculate where it crosses the x-axis, can I get a pretty good without trying to count slope when I don't have all these things? Yes. Now, y-intercept is right here. How do I find an x-intercept of any graph? Oh, my picture's small. How do I find the x-intercept of any graph? Any equation?
You said it here.
I said it equal to 0. Okay? So, okay, so here I have x minus 2 equals 0. So what is my x-intercept? 2. So I have 2, 0, and also 0, negative 2 here. Or, yeah, 0, negative 2 for a y-intercept. So if I can graph both of those, I can make myself an imaginary line that goes through them. Now, this graph...
I thought we used long division.
We do use long division. That's the answer. I haven't showed you how to do it yet.
Wait, so the y-intercept is 0, negative 2?
Yep, because it's right here. That the b is your y-intercept. Okay, so we have x squared minus x plus 1. It's the first thing I do.
Take out an x.
So I have x minus 1 over x plus 1. Then what?
Find your domain.
So x such that x cannot equal
-1.
find my x-intercept.
Should be equal to 0.
Set the numerator equal to 0, so at x and x minus 1 equals 0. So I get 0, 0, and 1, 0. You do not have to show me any other work besides what you did. Does that make sense?
Yeah.
Algebraically, I should figure out how you got 0, 0, and 1, 0. I want to just know the setup. Y-intercept,
Everything, plug 0 into all x's.
0 into all x's. So that gives me 0 minus 0 over 0 plus 1. And we should have known it should come out to be 0 before I even started. Why?
Because if you have one x-intercept to 0, 0, you have
We have the x-intercept to 0, 0. It better be the y. Not to say we won't make a mistake, but if either of those happen, like if I get 0, 0 for my y-intercept, I better go back and check my x-intercept. Maybe I forgot it. The other thing is people tend to tell me that 6 over 0 is 0. Is 6 over 0 0?
No.
No, it's undefined, right? So it wouldn't be. Whatever you were trying to find, it wouldn't be a thing. Okay, vertical asymptote. The denominator equal to 0. So x equals -1. Horizontal asymptote. Okay, so the degree of the numerator is 2. The degree of the denominator is 1. So 2 is
Greater.
Greater.
We're gonna do the
so
slant.
there's none on the horizontal, right? But there is a
Slant.
How do I know there's a slant?
Because the
Exactly.
numerator
One
is
bigger than
greater
one.
It's exactly one bigger. Now there's times you'll have them where the numerator is bigger than the denominator, but it's going to be bigger than 1, so you don't have to do the rest. So it's exactly 1 bigger. So I write slant, and I find it with long division. Do not forget that you have to fill in placeholders. You have to do all that stuff. And do it with the original problem. Got it? Okay, so I have x plus 1. And I don't need any placeholders there, do I? No. And x squared minus x.
Oh, never mind. Don't listen to Connor.
Okay. And I don't really need a plus 0, but I'm going to do it just because. Okay, it's at the end. It's the constant, so I don't really need it, but I'm going to do it just so you see that I filled in my zeros. Okay, so what do I multiply x by to get x squared?
negative.
Not negative x, just x.
But then you make it.
But then I make it negative over here. So I have negative x squared minus x. So I have negative 2x. Because I distributed it through that quantity, right? What do I multiply x by?
2.
Negative 2. Because it's a negative 2x. And I'm going to stop. I don't care how they end. Do I have y equals mx plus b right here?
Yeah.
Yes. I do not care about the rest of the problem. So I have a y-intercept, and on my paper, I always go 0, negative 2. It's my y-intercept. Where'd I get 0, negative 2?
You put in,
The original.
you set it equal to 0.
And
Not for my y-intercept.
Oh no.
you got it from the long division.
No, I got it right here.
The long division.
No, I got it right there. It's y equals mx plus b. It says negative 2, yes?
Yep.
So that's where I got it from. Okay, and then I'm going to do my x-intercept. If you want to count your slope, you can. I just do x-intercept. X-intercept is set the thing equal to 0, so it would be what? 2?
2.
Okay, so now I have my asymptotes, my intercepts, and I can start graphing.
Wait, how did you get the x? Oh, you just.
I just set it equal to 0. Okay, so I hate that I don't have a bigger picture up here. Okay, so we got 0, 0. I got 1, 0. Vertical asymptote is at negative 1. Horizontal, there's none, but I have a slant, so I'm going to go through 2. And I'm going to go through negative 2. I would suggest don't put points on your points on there, because if you put a point there, what are you gonna try to do? Go through it, right? Like with your actual graph. Okay, now, is it going to be over here?
No,
Why not?
because it doesn't have an
Because
X
it's not in
intercept.
between.
There's no x-intercept over here, so can it be over here? No. If we find, now, is it going to be over here?
No.
No, because there's no x or y-intercept, is there?
No.
Nope. So let's do our our interval analysis and see where we're at. So what are the only two things that make,
X-intercept and the vertical asymptote.
If it's gonna lie,
I know,
can you recalculate?
I don't know. I think it has something to do with the recording, because it was recording. Okay, vertical asymptotes only and x-intercepts. Not slant, not horizontal, not y-intercepts, right? Okay, so negative infinity to what?
-1.
Negative 1 to what?
0.
Zero.
Okay, 0 to what?
1.
Yeah? You can do it. I know you can.
It's 1.
Oh.
Okay, and then 1 to what?
Positive.
Okay, look at your x-intercepts and your vertical asymptote. Did I include all those numbers? 0, 1, and -1?
Yes.
Yes. Okay, between negative infinity and -1.
-2.
Negative 2.
Okay, go to your reduced. So it'd be a negative times a negative over a negative. So it's all going to be what? Negative. Now, again, we already talked about it. It can't be in this part of the negative, can it? Because there's no x-intercept. So it has to be where?
Down there.
Right there.
Down here. And when I put my negative, I put it down there where it goes. I don't put it up here where I put those x's, because it kind of confuses your brain. Okay, so from -1 to 0, so we got to do -1/2, right? Okay, so I put it in the numerator and get a negative and a negative, and the denominator I get a nope,
Or
positive. So I have an even number of negatives, so it's going to be positive. So it's going to be up here. Probably should have already guessed that, right?
Yep.
Because of the way those asymptotes are meeting. Okay, between 0 and 1. 1/2. So I get a positive, negative, positive, right? And so the whole thing is what?
Negative.
Negative.
What?
There's one negative.
Yeah, I know.
Okay, which honestly we should have known, because we have to come from the positive down through those, right? And the next one better come out to be what?
Positive.
Positive.
Or we missed it.
Or we did something wrong, right? This is also the reason why I do x-intercepts, because if you count the slope and you count it wrong, what if I went between like 1 and 2 with my slope because I wasn't paying attention? Would that mess everything up? Yeah, because you'd have to cross an asymptote, which you can't do. But again, slant only affects the negative infinity to positive infinity when there's middle sections. Okay, so 2, I get a positive, 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 so the whole thing is positive. So this one comes here. I can't see. Comes down. I don't know how far it comes down, but it goes back up and then off. Along that asymptote.
To be honest with you, I thought that. Okay, so you see the 2 dashes on the bottom? I thought that first one was a point for a second.
Yeah,
No
And I was
way.
wondering what was going on.
Because it was lagging and I just didn't realize it.
You see?
So is there anything different?
Not really.
One, only one step, right? And is it going to happen every problem?
No.
Today it is. But normally, is it going to happen every problem on your
No.
test? Is it going to happen every problem? No, it is not going to happen every
It's more
problem.
work, so probably.
Okay, and this is what we had, and I don't know why I have the picture there. Okay, let's do another one. One more. I am going to give you a 2 minutes head start. Because do I start this problem exactly the same as any other problem? Yes. Okay, did you get everything there?
Yeah. But
You
my
just
graph
slant-
is not great.
What?
My graph is not great.
Your graph is not great. Okay, it's y equals x because I came down to -2 and I can't make x equal -2, can I?
Nope.
Nope. So it's just y equals x. It's that identity line that inverses reflect across. Okay, so, ooh, that's horrible.
I mean, it's just straight through.
And there's sometimes that I don't even like put my y-intercept because I don't want to have to try to go through it, but sometimes I do. Okay. I label it afterwards. And see, this is one. We'll just make a bigger one. Do I got them all? Oh, slant.
How do you know it goes that way?
How do I know it goes that way?
Yeah.
Because it's y equals x, so the y-intercept is 0 and the slope is 1.
Okay.
And if the y-intercept is 0, what does the x-intercept have to be? 0. Right. Okay, so I think I know what this looks like. Is it going to be down here?
No.
No. Is it going to be up here?
Nope.
No, because this is a function, right? And it has to go through there, yes?
Yes.
And this is going to kind of, okay, so we better get negative, positive, negative, positive, right?
Yeah.
Okay, so what are my intervals? And I spread mine out so I'm not squishing. You have a half a piece of paper, you might as well use it on the problem, right? Okay, so -3, work. Putting it into my factors, because it's just kind of easier to see what's going to happen, right, with the factored ones. So it'd be negative over a negative. So the whole thing is going to be what? Negative. And that's what we said it should be, right? And again, how do I know it's here and not down here where the x is? My y-intercept and my asymptotes, right? If I had a y-intercept down here where the x is, could I have it down here? Yeah, but I don't. Okay, so 0. So I get a negative, a positive, a negative, so the whole thing is positive. Why is it positive?
2 negatives equal positive.
Yep. Okay, and then what? 3/2?
Why 3/2?
Because they have to be between 1 and 2. So you need 1 1/2, which is 3/2. A half would be between 0 and 1. A half would be over in this interval.
Oh.
And that's another thing, guys. If I'm not picking numbers in my interval, is it going to mess it up? Yeah. So that's where I always check. Make sure I got them in the interval. Okay, so 3/2 is still smaller than 2, so that first quantity is going to be a negative, right? And then a positive, but it is bigger than 1, so it's going to be a positive. So the whole thing is what? Negative. Is that what we said we thought it was going to be? Yep. Okay, 2 to positive infinity. And I get a positive, and a. So the whole thing is positive. Oops. What's wrong about what I just did?
It's going away from it.
It's going away from the asymptote. It looks funny there, doesn't it? I did it again, but oh well. My arrow didn't show up very well.
I refuse to believe that will never touch that line.
Yeah.
It won't.
Wait, it won't.
It's
going
going
to.
It never.
It's
No.
going to. I'm telling you.
It's going to be so close you can't tell the difference mathematically, but it will never touch it.
20 years from now, mathematical people will figure out that it does.
Well,
It's not gonna
considering
touch
those asymptotes been around for about 200 years, I don't know if the next 20 years would change that, but I guess. Maybe you, CJ, maybe you will prove
Right.
that they touch.
Good luck.
Okay.
I'll help you because
So
maybe
There's no
math is
way.
the only thing, well, I can show
If they're
you.
like magnets, it's gonna touch
No, it
eventually.
brings it towards it, but it's not going to touch it.
You're telling me that goes on forever and it's never ever
gonna-
gonna
It
touch
is
that.
never-
It's just gonna be like this the whole time.
It's going to get so close you can't tell the difference.
So if
'Cause
it's gonna
let's
get
say-
so close, it's eventually gonna go. Ting,
Nope.
cross right over.
Nope.
Yes.
Okay, so the only difference in the whole thing that I do today is what?
That's
Slant.
Slant. Every problem today I think has a slant.
No.
For a
That's-
reason.
that's okay.
Because you need to make sure you're doing them right. Okay? Do
Yeah.
you feel you need one more?
Our problems have evolved
Sure.
from half a sheet of paper to almost a full sheet of
Yeah.
paper.
No, you should just divide smaller.
Yep,
I
yep. I'm gonna
still
do
am at
long
half.
division.
Okay, that was theirs. Ours was better, right?
Oh, that's kind of even. I kind of like. Or even.
Why did they have so many points
Oh,
Right.
ooh, this
No.
one's fun.
No, I'm actually gonna have to use the restroom at this time.
Okay, this one is a difference of cubes, and difference of cubes has a special rule to factor.
Oh, those are fun. Yep.
It's
More
fun.
rules. More rules.
Okay,
No.
so the rule. Do you guys all see that there's a difference of cubes? That
No.
8's a cube. What's the cube root of 8?
Two.
2. What's the cube root of x cubed?
3
X.
3.
3. I
Yep,
don't
yep,
think
it's
so.
3.
Okay, so my denominator, does my denominator factor
No.
with real factors?
X plus 1, X plus
No.
No.
X plus 1, X minus 1.
No.
No,
It could be x plus I and x minus I
No.
Can it be?
because it's what, guys?
It's fake.
It's positive. So they're imaginary. So my denominator is what it is. Okay, my numerator is,
Is
what
x.
is the cube root of x cubed?
X.
X.
So it'd be
X minus
Okay,
2
shh.
cubed.
X minus two.
Minus, what's the cube root of 8?
2.
2.
You do that 3 times.
No, you don't.
What?
No, you don't.
You do x plus 2.
And then now, you take the first term and square it,
X squared.
x squared. You take the opposite sign,
Negative, positive 4.
positive. You multiply the 2 together. 2
2x.
times x is
2x.
2x. And you square the last,
4.
4. And it's always going to be plus. You should have been introduced to this in Algebra 2, but I know. I said you should have. I didn't say you should have mastered it. I didn't say you should know it now. I said you should have been introduced to it. That's it. Okay. What you guys were telling me to do was this.
Yep.
That is not what I have written there.
That's Connor's.
Okay, when I cube that out, I do not get that, do I? Because I have to FOIL the first 2 and then FOIL it again. I do not get that. This rule is always the same. The cube root of the first, the same sign, the cube root of the second. This goes for sum or difference of cubes. Got it? Cube root of the first, same sign, cube root of the second. You square, now this becomes your first and your second. You square the first, you take the opposite sign, you multiply the 2 together, and you square the last, and it's always a positive because whether it's a negative or a positive, when you square it, it's going to be what? Positive. Yes, Connor.
So I got a question. Is there going to be some of these on there?
On your homework, there is going to be one. Okay, this is for sum or difference. Okay, I'm going to go back real quick, and I'm going to give you 27 x cubed. My pen doesn't like up there. 27 x cubed plus, need another cube, 64. Okay, what's the cube root of 27?
9. 3.
3. What's the cube root of 64? 4.
4.
Okay, so the rule says I cube root the first thing. So the cube root of 27 is what? 3. The cube root of x cubed is x. Same sign. The cube root of 64 is 4. Now this is my first thing, this is my second thing. Got it?
Okay, now you square.
Square the first,
9x squared.
9x squared.
9
Opposite sign,
minus
multiply the 2
12x.
together,
12x.
and square the last.
16.
Now, this right there will never factor. It will never have real solution. It doesn't. Okay? So you can check it if you'd like, but it doesn't.
That's a lot.
on that.
But it works. You saw how I did it. Cube root. Once you take the cube root, it's pretty easy, right? You just kind of go from there.
Yeah.
Okay.
Yep.
But there is one on your homework, and I expect to have to do it tomorrow, but I expect you to try it. Got it? Okay. So,
Do that.
what's the only thing going to be different here?
The plan.
Okay, what's my domain going to be?
A domain.
X such that X
Not equals 0.
all real numbers.
All real numbers. Why?
Because it can't be imaginary.
You're gonna
It would be
subtract the 1, right? It's going to be x squared equals negative 1, and you can't do that.
Nope.
Can't
no
you divide
way.
the X by 2 though?
Well,
You're not dividing by 2, you're taking the square root.
then square thing of one.
And you can't square root of negative 1 is imaginary.
Sorry.
Okay, x-intercept. And I know you're putting things away, I'm just going to finish it out, watch. X-intercept is the numerator, right?
Yeah.
And I told you this right here would never factor.
So just use
So you're going to just use the first one.
Oh, so that's just irrelevant. They're irrelevant, dude.
It's non-real solution. Okay? And it is every time. So then the y-intercept, go to the original. So 0 minus 8 over 0 plus 1. So negative 8. Vertical asymptote is what?
A number 0.
None.
None.
None yet.
Why is it none?
Because there's
Because if it's
not
all
a
real
domain.
numbers.
If it's all real numbers, there's no vertical asymptote, correct?
Yeah.
But do I have to show you why it's none? Yes. Horizontal asymptote. 3 is greater than 2,
None.
so it is
None.
none, but it is greater by exactly
With the slight-
1. What do I need to remember to do here? Fill in
Fill
what?
The blanks.
The blanks. That's why this one was here.
Can you make sure you start it?
Okay, that was why I wanted to get to there. Fill in the blanks, guys, okay?
Oh.